All right, Kim 1. I want to work on ideal gas law. We'll say the third time's a charm. I've been having some trouble making videos today, so hopefully this one works out. In the past, I've taught ideal gas law first, and then taught Boyle's Law, Charles' Law, and Gay-Lussac's Law from that. This time we went a little bit different order, taught Gay-Lussac's Law, Boyle's Law, and Charles' Law. And now today I want to show you how to do the combined gas law. As the name implies, it's combining all the gas laws. So it's pressure, and the reason we do this is because that's more realistically what happens. The pressure changes, volume changes, temperature changes, all change at once. So pressure P1 V1 divided by T1 equals P2 V2 over T2. Now, just as a quick refresher, if temperature is held constant, it doesn't change, I get P1 V1 equals P2 V2, which is Boyle's Law. And I can do the same for holding pressure constant. I get V over T. If I hold volume constant, I get P over T. So you can see I get all three laws there combined. In fact, that's what sometimes I've taught the students to use this formula. If temperature doesn't change, leave that out. That way you only have one formula to memorize. But in this case here, we're going this direction, so I want to show you how to do a problem. I'm going to do the first problem on the worksheet. That does not mean that's one of your four to do. You still have four to do, so number one doesn't count. But let me read the problem. It says, argon has a volume of 224 liters at STP. What volume will it occupy at 27 degrees Celsius and 740 millimeters mercury? Now what I like to do is figure out what is my unknown, what is missing. You have 6 variables. Obviously, you have to be given 5 of them. So we're told, here's our initial stuff at STP. And remember, STP stands for standard temperature and pressure. For standard temperature, it's 0 degrees Celsius or 273 Kelvin. And for pressure, it's 760 millimeters, or 1 atmosphere, or 101.3 kilopascals. So in this problem, I'm asked to solve for V2. What is the new volume? So let me circle that. In fact, I would do that as you're learning this. On every problem that you're solving, put this formula, and then circle what it is you're asked to find. Then solve for that. Now I know there's 2 ways of doing this. You can plug the numbers in and then solve for what's missing. What I like to do is solve for the missing and then plug numbers in. To me, that gets a whole lot less confusing mathematically. If you keep track of units, it really doesn't matter, but I know some of you don't like units and you get lost in the units. So I think it's a lot easier to do it this way. So let me start out by saying I want to solve for V2. So I've got P1 V1 over T1. I bring T2 up, just doing cross multiplying, bring P2 down, and that then equals V2. Now let's go back to my problem. Since I'm given millimeters of mercury as P2, I want P1 then to be in the same unit. So P1 is 760 millimeters. Remember, I'm told it's at standard conditions. The initial volume is 224 liters. The initial, the new temperature, we're told, is 27 degrees Celsius. Add that to 273, you get 300 Kelvin. T1, the initial temperature, was 0 degrees, standard temperature, or 273 Kelvin. And notice I put it underneath the other unit just so units cancel. Distributed property, I could have put that any place I wanted in here. I chose there just so it lines up. And P2, we're told, is 740 millimeters. And nothing goes in this box. It doesn't mean it's 0. I mean, you can put an understood 1 there if you like. It doesn't matter. Okay, now it's time to do the mathematics. Now, I know a lot of you like to multiply the numerator and then the denominator and then do it. Let's try that. So we get 760 times 224 times 300. I get a very large number, 5107200. And then in the denominator, I get 740 times 273. And I get another large number, 202020. Then I divide that, and I get 252.8. However, keeping it to two significant digits, I get 250. And I'm sorry, I didn't write that in there. The unit left is the liter. My apology. Again, that should have been liter stuck in there for the unit. Mathematically speaking, I could have said 760 divided by 740 times 224 times 300 divided by 273. Again, it doesn't matter mathematically speaking. So I hope that helps on how to do this. Please ask questions, send me emails. I know we've gone through a lot of material. We're going at a fast pace, be doing this at home, but it's actually slower paced. We'd be doing it if we were at the school. So I really want you to get this. Keep plugging away at it. Go to Khan Academy if you want to see more videos. Miss Hamilton also has a video on this same unit. You can watch her video, hear it from a different person, might help you. Just try to grab a hold of this as best you can so we can keep moving forward. Okay, I hope you're having a good day.